every weather bulletin on your phone since around 1990, every automated sports recap, every canned Slack notification, every "your Uber driver Miguel is 3 minutes away," all of them are natural language generation. And for most of that history, none of them used a neural network. They used slot-filling templates, Mad Libs for grownups, and they worked better than the neural systems that tried to replace them. This video, how NLG evolved from filling slots in canned sentences, to statistical models that could vary the phrasing, to modern LLMs that generate coherent essays from a 2-line prompt. And the strange fact that the 3 classic pipeline stages, content selection, planning, surface realization, never actually died. They just moved inside the model. Last video ended with summarization. Article in, summary out. But summarization always has a source document. NLG has something weirder as input: structured data, a weather record, a row from a database, a meeting transcript, or nothing at all, just a prompt. And the job is, turn that non-text stuff into fluent English. That is a much larger open problem than summarization, and it dates back to the 1970s. Today's puzzle: NLG failed for 40 years. Neural NLG made things worse before it made them better. Then, LLMs seemingly solved it overnight. But if you look inside what a modern LLM does when it writes a paragraph, the 3 classic pipeline stages that people identified in the 1990s are still there, hidden, and still what breaks when the output is bad. Today's 3 beats. First, the classic NLG pipeline. Reiter and Dale 2000. Content selection, text planning, surface realization, template-driven Mad Libs. Boring, effective. Second, statistical and neural NLG. Data to text with sequence models. The E2E NLG challenge, where the neural approaches started outperforming and where they still routinely fail. Third, the LLM era. Prompting replaces the pipeline, except it doesn't really. The 3 stages are still doing the work and still causing the failures. Beat 1. Reiter and Dale 2000. Building Natural Language Generation Systems. The classic textbook. They named 3 stages. Content selection. What to say. Given a weather record, do we mention wind speed? Text planning. What order to say it? Do we lead with the high temperature or the storm warning? Surface realization. The actual English words. Tomorrow it will be versus expect tomorrow to be. These 3 stages formalized what template systems already did informally. In practice, most 1990s and 2000 systems skipped straight to templates. Fill slots in a canned sentence. The weather in city was 80J today. Plug in sunny, Denver warm, ship it. This is how every automated weather bulletin worked. Every automated sports recap. Every early financial report generator. It's laughably simple. It also, literally, cannot hallucinate. If the template says the temperature comes from the record. The obvious limit: templates cannot handle variety. 10 weather bulletins in a row all sound identical. Editors hated it. Readers noticed. And the moment your data has a shape the template designer didn't anticipate, a hurricane on a sunny day, the output either breaks or lies. So the field started asking, can we make this less stiff without giving up factual grounding? Beat 2. Statistical NLG, the first fix. Instead of handwriting 1 template per weather condition, learn many phrasings from a corpus. Given a data record, pick a template weighted by how good it looked in training. That gave variety, but still stayed close to real examples. Then in 2015-ish, Sectuasic arrived. Novikova and colleagues built the E2E NLG challenge in 2017. Structured meaning representation as input, freeform English as output, neural network in the middle. The problem: neural NLG traded stiffness for lies. Same failure mode as abstractive summarization last video. Models hallucinated fields that weren't in the input, dropped fields that were, produced grammatical English about a restaurant that didn't exist. The E2E paper found that even the best neural systems had roughly 40% of outputs containing some kind of factual error. Templates never had this problem, because templates cannot invent. The mid-decade NLG survey, Gatt and Cromer 2018, is where the field admitted this. Neural NLG produces natural output, Templates produce accurate output. Neither one produces both. Everyone knew a fix was coming. Nobody knew it would arrive as an unrelated general-purpose model. Beat 3. The LLM era. GPT-3 and its successors were trained to predict the next word on hundreds of billions of tokens of internet text. As a side effect, they can generate coherent long text out of a prompt. No task-specific data, no fine-tuning. You draft a 3-paragraph weather report from these fields and hand over the record, and it does. But look at the failures. When an LLM produces a bad weather report, what went wrong? Sometimes it invents a field. That is a content selection failure. Sometimes it puts the storm warning at the end. That is a text planning failure. Sometimes the grammar goes sideways. That is a surface realization failure. The 3 stages Reiter and Dale named in 2000 are still what breaks. The LLM just does all 3 at once, badly, in one forward pass. The practical answer in 2026. Hybrid systems. Use an LLM for surface realization, the part it's great at. Use a template or a structured planner for content selection, the part it lies about. Modern data-to-text products often generate their outlines from a rule system, then hand the outline to GPT for phrasing. Boring templates on the inside, fluent English on the outside. Both worlds, for the first time. 3 takeaways before the quiz. 1. Reiter and Dale 2000 named the 3-stage NLG pipeline. Content selection, text planning, surface realization. Templates handled the whole thing informally for decades and never hallucinated. 2. Statistical then neural NLG. E2E challenge, Novikova 2017 gave variety but introduced hallucinations. The 2018 GAT and Cromer survey admitted no system did both fluency and facts. 3. LLMs. Made prompting replace the pipeline, but the 3 classic stages still exist hidden inside the model, and they still cause the failures we see. Hybrid rule plus LLM systems are the current fix. Quiz 1. What are the 3 stages of the classic Reiter and Dale 2000 NLG pipeline? A. Tokenization, tagging, parsing. B. Content selection, text planning, surface realization. C. Encoder, decoder, attention. Or D. Extract, transform, load. B. Content selection is what to say. Text planning is what order. Surface realization is in the actual words. 26 years later, an LLM writing a paragraph is still doing all 3 of those things, just implicitly. Quiz 2. Why did template-driven NLG dominate weather bulletins and sports recaps for decades? A. Templates were the state-of-the-art at every benchmark. B. Templates cannot hallucinate. Every fact in the output comes from a filled slot, so factual accuracy is guaranteed even if variety is not. C. Templates were the only way to run on GPUs. Or D. Templates were legally required. B. The temperature in the output is literally the temperature from the record. No model, no stochasticity, no invention. The trade-off is monotone output, which readers eventually notice. But when your data has adversarial shapes and your users need accuracy, templates ship in 2026 too. Quiz 3. How do modern hybrid NLG systems get both fluency and factual accuracy? A. They train a bigger LLM until hallucinations disappear. B. A rule-based or template planner selects content and orders it, then hands the outline to an LLM for phrasing. C. They translate everything through French. Or D. They use 2 LLMs. Voting. B. This is the shape of most production data-to-text pipelines in 2026. A deterministic planner controls what facts appear and in what order. GPT handles the surface English. Best of both worlds. The rules cannot invent. The LLM cannot be boring. Back to the puzzle. NLG never really died. It just changed shape. Reiter and Dale's 3 stages are still what breaks when an LLM lies or repeats or slips. Modern systems pin the stages you cannot afford to lose to rules and hand the rest to the model. Next video, the audio side of the pipeline. Speech recognition, from raw sound waves to typed words. Next time, speech recognition, audio waveform in, transcript out. MFCC features HMM, GMM decoding, then the deep learning revolution, then Wave 2.0 then Whisper doing near-human recognition in 90 languages. The whole arc in 8 minutes. Hit subscribe.